We've looked at a couple of options for how we might be able to store data. We're going to start thinking a little bit about how we might model data for different purposes. And data modeling is basically the idea of taking the real world and determining how we're actually going to represent that in our data storage. A lot of people might look at things in the real world and sort of translate that directly to a database exactly as they are, but sometimes it's a little bit more effective or efficient to store data in some other ways. And one of the topics that you'll think about when you're thinking about how or exploring how to model data is normalization and denormalization. So normalizing or denormalizing data, there's actually reasons to do both. When we structure and store our data, we have to think about a couple of different questions. How often we're going to create new data? What's the rate of creation of data in our application? How often we need to update that data. Some applications may only create data. They may never actually update any of the data that they store. So we have to ask, will we ever update any of the data? And then another question is, how often we'll retrieve data? So we typically think of 4 different operations when we're dealing with any type of data. We often call those CRUD operations, C-R-U-D, create, retrieve, update, and delete. So typically when we're dealing with data, we do one of those 4 things. And it's good to think about the application that you're going to build and how much each of those operations will occur. How often will we create data? How often will we retrieve data? How often will we update data? And how often will we need to delete data? And the sort of proportional relationship between those can tell you a lot about how you actually should manage and model your data. So denormalization sometimes is better illustrated with an example than with an explanation. So when you have denormalized data, basically fully denormalized data means that every single thing that you need is available in one place. It's all available in one record. So if you need a bunch of information about courses, you can find all of that information in one record here. If you look at the content on the left, you've got the course number, you've got the course title, you've got the instructor, and that can be very efficient when you need to retrieve data because you don't have to do any. You don't have to go look at multiple tables. You don't have to look at multiple sources of data. However, updating is maybe not quite as efficient that way. So when you normalize data, and you look here on the right, we kind of have the data separated out into courses and then into instructors and then to course instructors to associate the two. When you normalize the data, updating becomes much easier. So if we look at the data on the left, if we wanted to update the name of the web development course, we'd have to update at least 2 records. Whereas on the right, the normalized data, if we want to update the name of the web development course, we'd only have to update 1 record. And that's a pretty simple and straightforward example, but if you could think about how this kind of data might evolve over many years and how we might have many, many records, normalized data basically means we're going to try to not duplicate any data in our storage, whereas denormalized data means that we are going to duplicate a lot of data in our storage. And when you normalize, you make your data a little bit more unique. The process of normalization is basically making sure that none of your data is stored in duplicate ways. Whereas denormalized is really the idea that you're going to start storing your data so that it is very duplicated, but it's done for efficiency purposes. And in a relational database management system, you're going to join tables together. So each one of these courses, instructors, and course instructors would be a table, and you would join that. And if you needed to use any type of query or reporting, these joins would be used to kind of create this on-the-fly denormalized data. But that process takes time and processing. So denormalized data has repeated entries. Normalizing data is the process of eliminating that redundant data. You're eliminating duplicate data. So, ideally you only have one place for every bit of data that you need to update anything. Denormalization involves duplicating data in ways that make it easier to query. So when we're denormalizing, sometimes that can be very valuable because we don't have to do any extra work to make that data accessible. We can access it very quickly. Normalization separates data into different tables or other logical structures. We often use some type of references. We'll talk about IDs and foreign keys and things like that. Normalization is the process of separating these things, but providing some kind of structure so that we can put them back together again. With denormalization, we introduce some complexity in updating, but it does simplify retrieval. There's not as much work necessary to get the information you need. With normalization, you make retrieval a little bit more complex, but it definitely simplifies updating data. And this is actually a pretty important factor, because if we don't update our data in consistent ways or effective ways, we run the risk of having all of the integrity of our entire application lost. So sometimes normalization can be the only safe choice. But we often use denormalization when we're doing reporting, or if we're building a data warehouse. That can be much more effective in those situations. So when we're thinking about creation of new data, if we create data more frequently than we update, then sometimes we might just want to append to a file. If we hit, like if you're writing a log, sometimes just creating a log file is going to be your most efficient case. Sometimes you just want to keep outputting some kind of data. If you're reading out sensor data or something like that, sometimes updating to a file is going to be more efficient than any of these other options. If we're updating our data frequently, then a relational database management system may be more effective for maintaining that level of update. If you never have to update your data, then data warehousing might be a good solution, because you can just output all of that data to a data warehouse and then use tools to access that very quickly. And if retrieval is much more common than updating, then we can sacrifice some of the efficiency in updating to make our reads very fast. And if you think about this, sometimes applications never update data. Sometimes they only create data, but they do need to be able to retrieve it and aggregate it in effective ways. And if you think about a lot of the applications that you might use, you could kind of think about how they could be used to create new data. And every time you hit edit, it could just create a new edit. And a lot of times you can see the history of updates. And maybe that's exactly what's happening in those situations. We're never actually updating any data. We're just creating new and new and new data. So hopefully this will give you an understanding of some of the concepts involved in normalizing and denormalizing your databases and your data storage mechanisms. We're going to continue to talk a little bit more about data storage concepts over the next few lectures. And hopefully after we get through 5 or 6 more of these, you'll have a good understanding of how to approach data modeling and data management in your application. Thanks for watching.